Hi folks, welcome to your starter solutions for today. First question is asking us the mass of 1 mole of glycerol, okay? So we just basically need to work out the gram formula mass of glycerol, which is also known as propane 1,2,3-triol. So remember it's got that carbon backbone, 3 hydroxyl groups, and 5 hydrogens, okay? So the formula could be written as C3H5OH in brackets 3, where the total of what's in here, the total of what's in here is 17. So 17 times 3 is 51. And then the 5 from the hydrogens, and then 36 from the 3 carbons. So 51, add the 5, add the 36 is 92. So the mass of 1 mole of glycerol would be 92 grams. Okay, it's just the formula mass expressed in grams. Okay, our next question is the mass of 0.025 moles of isoprene. So remember, isoprene, the isoprene unit has the formula C5H8. It's got 2 double bonds in that carbon chain of 4 carbons, and then remember it looks like this. Okay, and it has 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. So we just need to work out the gram formula mass. So we've got 8 hydrogens, so 8 ones are 8, that's fine. And then C5, 5 12s are 60. So that gives us 68. So if we do if we do mass as number of moles multiplied by the gram formula mass. So 0.025 multiplied by 68 is 1.7 grams, and that is our final answer for this one. Okay, so next we've got how many moles are present in 5.1 grams of butyl methanoate. So I think the easiest thing would be to draw butyl methanoate out. So we've got 1, 2, 3, 4, then the oxygen from the hydroxyl group that would have been in there originally from the butanol, yep. And then the 1 carbon from the methanoic acid, okay? So this is going to be the structure here. So we've got 5 carbons in total. If we were to write out the formula, the molecular formula, it doesn't matter what order we put things in, but we've got a total of 5 carbons, and we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens and 2 oxygens. Okay, so if we add that together then, let's just move this up here. Then we've got 2 16s are 32 plus 10 plus 5 12s are 60, so 70, 102. So that's how much 1 mole weighs, okay? So if we want to know the number of moles, that would be the mass divided by the gram formula mass. So that's 5.1 grams from our question divided by 102, which is 0.05 moles. To make that clear, that is our final answer. Okay, so next one, write an equation for the combustion of hexane. Use your equation to calculate the mass of carbon dioxide that would form when 10 grams of hexane reacts with excess oxygen. Okay, so first of all, let's get our balanced equation ready. So we've got hexane is C6H14. Remember, it's an alkane, so CnH2n plus 2 is the general formula, plus O2. And we always get carbon dioxide and water as the products, okay? So the number that goes in this position here is always the same as the number of carbons, okay? So that's going to be 6 to give us 6 carbons. And then to work out the number of hydrogens, so we've got 14 here, so we're going to need 7 here. All right, so how many oxygens has that given us? to make sure our equation's balanced. So we've got 6 times 2, so we've got 12 over here, and then we've got 7 over here. So 12 plus 7, that's 19. So we need to multiply our O2 by something to make it 19. What I'm going to do, instead of having a decimal, I'm going to put a fraction in there. So I'm going to call this. So instead of having a decimal there, I'm going to put a fraction. So I'm going to put the 19 over 2 in front here. Okay, so let's just clean this up a little bit and then we'll be able to see what to do with our balanced equation. So the question says, how much carbon dioxide are we going to get when we react 10 grams of hexane? Okay, so the mole ratio is 1 to 6, okay? 1 to 6 moles. So for every 1 mole of hexane, we would get 6 moles of carbon dioxide. What about the GFMs for these? Well, the hexane, C6H14, 12 sixes plus the 14 gives me 86. And for carbon dioxide, that's 44. Okay, so 86 grams should give me 44 times 6, which is 264 grams, okay? I'm going to start off with 10 grams. So I'm going to end up with 264 divided by 86 times 10, which is 30.7 grams. And I'm just going to move that, just going to pop that onto there and then move on to the next one. Okay, so in this question, we're asked what is the percentage by mass of oxygen in pentanoic acid? So pentanoic acid looks like this. We've got 1, 2, 3, 4, 5 carbons, and then the final carbon is part of a carboxyl group. So the formula is going to be C5H10O2, okay, molecular formula. And in fact, it's the same as the one that we had for butyl methanoate, so it's going to be 102 grams. So the total mass of the atoms is 102 grams for 1 mole. And we want to know how much of that is oxygen. So we've got 2 oxygen atoms in the formula. So each oxygen has a relative atomic mass of 16. So that would be 32. So 32 over 102 is 31.4%. Okay, so just to recap, this is the total mass of oxygen and this is the total mass of all the atoms. Okay, the last one here, a 6 gram sample of sodium hydroxide dissolves to form a 100 centimetre cube solution. Calculate the concentration of it. So this information here allows us to work out the number of moles. N equals M over GFM, where M is 6 and the GFM for sodium hydroxide 1 plus 16 plus 23 is 40. So 6 over 40 is 0.15. That's how many moles we've got. And then we combine that with this information, which is a volume. So we can do we're trying to work out concentration, which is number of moles divided by the volume. So 0.15 divided by the volume, which is 0.1 litres. Remember, we always need to convert centimetre cube to litres. And therefore, the answer is going to be 1.5 moles per litre. And that is our final answer for this one.